All right, guys, you are listening to this because I am not feeling well and I'm out sick. So in class, we started example 2A and we were done with 2A. So we were going to start example 2B. We got the triangle drawn out, but let me just kind of redraw that with you guys, just in case some of you guys weren't there. So sine of theta equals radical 5 over 5, and cosine of theta is negative 2 times rad 5 over 5. So we are going to draw a coordinate plane. Remember, sine is positive at 5 over 5, and sine is positive in quadrant 1 and quadrant 2, because sine is y. Then cosine is negative. Cosine is x, so cosine is negative in quadrant 2 and quadrant 3. So as you can see, they meet up in quadrant number 2. Now, in theory, sine is going to be opposite over hypotenuse. So we're going to say, okay, opposite is radical 5. Hypotenuse is 5. Cosine is adjacent over hypotenuse. So adjacent is negative 2 radical 5. Hypotenuse is 5. And this looks perfectly fine. There's nothing wrong with this. Now, but what's happening is we can go and unrationalize this, okay? So sine of theta is currently radical 5 over 5. But if we multiply the top by rad 5, the bottom by rad 5, we would have 5 on the top, okay, and 5 radical 5 on the bottom. And this will give us 1 over rad 5. And you can see what's going on in a little bit. Similarly with this, we're going to multiply top and bottom by rad 5. Remember, we're trying to unrationalize, okay? So cosine of theta is now. So on the top is going to be negative 2 times 5. On the bottom, 5 rad 5. So those will cancel. So it's negative 2 over rad 5, okay? Now, if we were to use this, either one will get us the right answer, okay? So we already know it's in quadrant number 2. If we go and said, okay, sine is going to be opposite over hypotenuse, cosine is going to be adjacent over hypotenuse, then when we use the unrationalized one, then we don't have to do a lot of simplifying later. Now, if we use the original measurement, it's still going to give you the same answer, but you will have to do some simplifying later, okay? Right, it says here, find the exact value of the remaining trig. So they gave us sine, they gave us cosine. Currently, we just need tangent of theta, cotangent of theta, and then we need the reciprocal of sine, so which is cosecant of theta, and then secant of theta, okay? Cosecant and secant, guys, we could just find it pretty easily. Let's go find cosecant. Cosecant is the reciprocal of sine. Sine is 1 over rad 5, so cosecant is just going to be rad 5. Secant is reciprocal of cosine, so that's going to be a negative radical 5 all over 2. Tangent is going to be opposite over adjacent, so it's going to be a negative 1 over 2. And cotangent is reciprocal of that, so it's going to be a negative 2, and box that up. So example C says cotangent of 1 over 3, okay? Now it gives us sine is less than 0. And remember, less than 0 means it's going to be a negative, so we want to determine the quadrant that will contain the one quadrant only that will make these two things true. Cotangent is positive in quad 1 and quad number 3, because cotangent is x over y. For cotangent to be positive, both x and y have to be positive, or both x and y need to be negative. Sine is negative, okay? Sine is negative in quad 3 and 4. So guys, they meet up in quad number 3. So cotangent is adjacent, which is going to be 1 over 3, opposite, right? But we're in quad 3, so this is going to be negative 1, and this is going to be a negative 3. Then we need to find your hypotenuse, so it's going to be a squared plus b squared equals c squared. You can use negative and then make it a quantity. It doesn't really matter when you square it. Things will be positive anyway. Okay, so this is going to be 1 plus 9 equals c squared. C squared equals 10, so that means c is going to be square root of 10. Hypotenuse would never be negative, so because hypotenuse is a length. They're all going to be positive, except the negative is just telling us what quadrant we are in. So we want to find the remaining trig function. So let's start with sine of theta. Sine of theta is opposite, which is -3 over -3 over square root of 10. Rationalize that by multiplying top and bottom by square root of 10. So your final answer, in which we will box, is going to be -3 radical 10 all over 10. That is your sine. And then we can do cosine is adjacent, which is -1 over hypotenuse. And then we're going to multiply top and bottom by rad 10. Final answer, guys, is going to be -rad 10 all over 10. Then next is going to be tangent. Tangent, I'm just going to flip your cotangent, which is 3, so box that up. Reciprocal function of sine is cosecant of theta, which I'm going to flip the -3 rad 10, make it -rad 10 over 3, box that up. And secant, we are going to flip cosine, which is -rad 10. Alright guys, I want you guys to try out the check for understanding, okay? So hopefully you guys have the same remaining trig functions as I have here. Again, if you guys need some extra help, please come to tutorial, okay? So before we start the last example in this section of notes, I want you guys to think about what we have done so far. So we are doing the 6 trig functions from a unit circle, right? And as you know already, guys, let me just draw a line here. Your sine of theta, okay, is the same as y on the unit circle. Your cosine of theta is the same as x on the unit circle. Then, as we know already, if you have a unit circle, here's your unit circle, this is the radius of 1, this is y, this is x, and if y is the same as sine, and Pythagorean theorem said y squared plus x squared equals 1 squared, right? 1 squared is going to be 1, so I don't need to write a 1 squared. Then we can safely say that since y is sine, we can safely say that sine of theta quantity square plus cosine of theta, let me just unfreeze here. There you go. Cosine of theta quantity square equals 1. This is a true statement. But in trig function, guys, to not be confused with the angle being square, the way that this is written is sine square of theta, okay, plus cosine square of theta equals 1. This is a true statement that we have to know, okay? So I do need you guys to memorize this because sine square plus cosine square equals 1 is always true. So please memorize this. Now from this one really important trig theorem, guys, sine square plus cosine square equals 1, we are going to come up with 2 more by simply dividing, okay? So I'm copying down sine square of theta plus cosine square of theta equals 1. If I take each term and divide each term, students, by sine square of theta, okay, sine square of theta. Well, sine square divided by sine square is going to be 1. Cosine square divided by sine square, students, this is going to be cotangent square of theta because it's got x over y. And then 1 over sine, we already know that as secant, so this is just simply secant. Oops, cosecant, my bad, cosecant square of theta. So this is a second theorem, but it's easy to derive, right? Because all we had to do was divide by sine. Now the third theorem we will derive is going to be, I'm copying down the original. Now instead of dividing each and every term by sine, we are going to divide each and every term by cosine, just like this. Now cosine square, and cosine square. Well, sine square divided by cosine square, guys, is now going to be a tangent square of theta. Okay, and then plus 1 equals 1 over cosine. We already know that's secant square of theta. So these are the 3 theorems that we really do need to know. But if you know this one, this main one, by dividing each term by sine square or cosine square will get us the other 2. All right, guys, for this one, can you do me a favor and change this to multiplication? Okay, so instead of the addition, can you make it a big old dot? Okay, so again, make it a big old dot to do some multiplication. So we have 1 divided by cosecant square of 35 degrees, and we want to find the exact value, that means no calculator, times cosecant square of 35 degrees. So currently, as you can see here, when we're multiplying, we can have it over 1. So if we are multiplying, we can simply reduce this. Cosecant square can be reduced with cosecant square, so this is going to be a 1. It's just that simple. Okay. Then why don't you guys try the check for understanding here? All right, hopefully you guys got a 0 for that. All right, guys, another pattern I want you guys to recognize is so far. As you guys know already, sine of 30 degrees, oops, I wrote sim. Sine of 30 degrees is 1/2, right? Now, cosine of, if you think about this, 60 degrees is 1/2. Whoa, they are exactly the same. Now, let's kind of think about tangent of 30 degrees. Okay, tangent of 30 degrees, guys, is going to be rad 3 over 3. Well, cotangent of 60 degrees is also rad 3 over 3. So what I want you guys to understand is this pattern. If you guys have sine of an angle, okay, whatever that angle is, in this case, let's pretend it's 30, is going to be exactly the same as cosine of 90 minus theta. Okay, so 90 minus theta. So, and then tangent of theta is identical to cotangent of 90 degrees minus whatever that theta is. Okay, and then same thing with cosecant of theta. Then it's identical to secant of 90 degrees minus theta. So an example when we have to find the exact value and we can't really have a calculator. If we would ask to find sine of 20 degrees, guys, sometimes we can use cosine of 70 degrees. Okay, we use this theorem a lot when we just want to like reduce or simplify. Okay, so make sure we write this down and highlight and know what this is.